Hi everyone, I'm Michelle and I am in the first year of my PhD at the Paul Scherrer Institute in Switzerland. In our group, we study mid and low latitude high elevation glaciers. And for my video here, I thought I'd give you a little preview into some fieldwork we had for my PhD project earlier this spring. So here we drilled an ice core on Tödi, which is a mountain in the canton of Glarus in the central Swiss Alps. And it's located at about 3,600 meters elevation. And this is the first of 3 locations where we aim to drill an ice core in the Alps, ranging between 3,600 meters and 4,200 meters. The other 2 locations being Mont Colomb and Alphügel. And here you see a nice view of the glacier on the mountain on our way up. And yes, we had to wait 6 weeks to finally be able to go up. We just needed a 2-day weather window, but we had a very wet spring, and yes, we really just needed time to go up, drill a core the first day, sleep overnight in a tent on the glacier, and then drill a parallel core the second day and return in the evening. And finally, at the beginning of May this year, we were able to go up. And we had to take a helicopter because in the end, we had about 850 kilos of equipment, including the ice cores. And for safety reasons and logistically, and also with this small weather window, it just would not have been possible by foot. So this was the first core ever drilled on Tödi, and the glacier is about 20 meters thick. And we drilled 2 parallel cores all the way to bedrock. And we know we hit bedrock because the cutter was damaged. And the ice is also still frozen to bedrock, which is very important for my project. And so what is my project exactly? Well, we are attempting to understand the onset of neoglaciation in the Alps and assessing the minimum Holocene glacier extent. So today the glaciers are at a fairly minimum extent and continue to retreat, but do we know that this is unprecedented through the Holocene and Earth's recent history? It's difficult to say because glaciers, when they advance, they leave behind moraines, but they erase previous time. And so minimum periods are much more difficult to understand. And that's why we know a lot about maximums. And when we think of glaciation in the Alps, keywords come to mind like the Little Ice Age or the last glacial maximum. But for understanding how the glaciers will evolve in the future and with modeling of this, it's difficult to assess these minimum extents. So one of the things we can do is look at specific sites in the Alps at different elevations, which is what we're doing in this project. And as long as the ice is still frozen to bedrock, we can use radiocarbon dating to date carbonaceous aerosol particles that are trapped in the ice and attempt to measure the age of these particles. And this will help us understand the onset of glaciation when these glaciers on these small ice caps first formed. So that's a little preview into my project. I hope you enjoyed the footage from the fieldwork, and I'm looking forward to getting to know you all this week.